8.5 extra practice. We did some of them yesterday. Asked you to finish these other ones. Okay, to begin with this first problem right here, you're asked to graph it. Okay, we know that x equals 3 right there. It equals 1 right there. So we're able to put x-intercept of 1 and of 3. Meaning the axis of symmetry has to be halfway in between where x equals 2. That's our axis of symmetry. And then if we put 2 into our equation, we'd end up with 2 minus 3, or negative 1. And we'd have 2 minus 1, or 1. Negative 1 times 1 is negative 1 times negative 4 is positive 4. So our vertex is at the ordered pair 2, 4. Okay, we draw our graph. Okay, hopefully a bit better curve than I drew, but there we've got it. Questions on that one? Okay, tell your neighbor how you did on it.
Got it wrong.
Why'd you get it wrong?
Because I made it open up.
Yeah.
No. Unbelievable.
Yeah, man, crazy.
At least you know why. No.
That's for basketball.
Oh, dunk a shame. Okay, the next one we need a factor first. We end up with x times what? And x times what? What does that factor to? X minus 3? X plus 5? Okay. So this gives you x equals 3 and x equals negative 5. All right. Let's see. Okay. My axis of symmetry then, for those of you who want to use math on figuring it out, is x equals 3 plus negative 5 divided by 2, or halfway in between those. That would be negative 1. That's our axis of symmetry, so we go here. When we plug negative 1 into either here or here, if I go negative 1 here, that gives me 1 minus 2 minus 15. Okay, 1 minus 2 minus 15 is negative 16. So if I am doing negative 16, I am going to have to really change my scale up a bit on it. Okay? Yeah. So you did it correct.
I don't know if I did it right.
Did you get a vertex of negative 1, negative 16?
I did.
All right. You didn't?
I didn't.
Oh. How many got a vertex negative 1, negative 16? Okay. Okay, so if I'm probably going to have to go up by 5s here. So that'd be negative 15 right here. Negative 16 would just be right below it. Okay. I would have negative 15 right there. Okay. I would have an x-intercept of 3. So 1, 2, and 3. Y-intercept, or another x-intercept of negative 5. It's right there. So my graph, I have to curve that out a bit. Looks a lot wider, but that's because my y scale is not going by 1. So. Okay. Okay, tell your neighbor how you did on that one. How come? So how do you know? What do you mean you don't know?
I don't know how to do it.
Okay, so one of the questions I got earlier on was, how do you know where to put your x and y axis when you're graphing these? So first thing I'm going to start doing is listing what x equals here. So x equals negative 3 and x equals 1. Okay, those are my two x-intercepts. All right, my axis of symmetry is where I add those two pieces up, negative 3 plus 1, and cut in half. I find the halfway point. So that gives me negative 2 over 2, or negative 1. It's my axis of symmetry. And then my vertex, I plug that negative 1 back into my original equation. So my vertex is going to be, I'm going to have f of negative 1 here. And as I plug that back in, I get negative 2 times negative 1 plus 3 and negative 1 minus 1. Okay? And so from there, it gives me negative 2 times 2 minus 2 is 8. Okay, so we have a vertex of 8 and negative 1 or negative 1, 8. All right. And so now I can, if I have a vertex of negative 1, 8, that means like in a graph on my axes, that would be like right there. Okay, and this graph is opening down because my negative value for 2. So I'd have to, it's going to look something like that if I do a quick sketch, meaning I really want to focus in on this part of the graph. Okay, so my axes need to be shifted over just a bit if you want, or you could, I mean this one is fine if you put at least one of them in the middle here. Okay. And maybe shift it, the x-axis down a bit. Okay, so you're kind of zooming in on that picture right there. So we get negative 1, 8. I'm going to go up by 2, 4, 6. Go up by 2s here. Give me 14. Okay, actually, I just drop this down 2 more units and then I can go up. I can just go up by 1s. There you go. So now I'm at 8. All right. What's that? Did I go 9? Oh, thank you. There, we got it. Okay, how many got that one? Okay, very good. Questions on them? Find the correct vertex, right? You following how we're doing with the vertex. Look it up. All right, number 11. First step. Factor.
Not my thing.
X squared times, or x times x squared minus 9, pull out a greatest common factor. Okay. I then look at what makes 0. That part becomes 0 at 0. And this part right here, you can either factor again by using difference of 2 squares, or you could just say, well, x squared minus 9 equals 0. I add 9, I get x squared equals 9. Take the root. Remember, when you impose a root, it's plus minus. Plus minus root 9, which is 3. So plus minus 3. So my zeros are 0 and positive negative 3. That means it is crossing the x-axis 3 times, which we have not done yet. Okay? And so what you're going to do on that, I'm just going to put a normal x-y axis. I'm going to put 0 there, crosses there, crosses there, and it crosses there. Yep. And this is a positive A term. That means my graph will start at the bottom on the left and end somewhere up here on the right. Okay, so I'm just going to make it go through. I don't know what the other points are unless I actually calculate them. For the sake of what we're doing, I'm going to just let you say I have to go through that point, come back through that point, go up through that point. Okay, if you wanted to do it accurately, which I'm not terribly concerned that the points in between are accurate right now, but you could always plug in values. Like if I put 1 in, 1 cubed is 1 minus 9. 1 minus 9 is negative 8. So this would actually be way, way down there. Okay. Once again, I'm not too terribly concerned about that. I'm more concerned that you put the correct zeros.
Will that still be declared a parabola?
That's not a parabola, no. That's a cubic function. So that 3 right there, the highest power you have will tell you the maximum number of times it can hit the x-axis. Doesn't mean it actually hits it that many times, but that's the maximum. This could not hit the x-axis more than 3 times. Just like our parabolas cannot hit it more than twice. Okay, so this one right here, the maximum number of times it can hit is 3 times. Okay, and so once again, this one's factor by grouping, factoring by taking out a greatest common factor. That's more of an accurate graph on that one. I'm not going to spend any more other time on that, but that would be an actual accurate graph on it, where you pull out your 2x, you find your zeros, okay, but then actually calculating points in between. Okay.